Hello viewers, hope you're all doing good. Welcome to this video. I'm Venkat and this is Just Me, an open source channel. Right, in this video I'm going to show you guys how to monitor your Kubernetes logs using EFK, the Elasticsearch, FluentBit and Kibana stack. The previous video that I released, not the previous one, I think it's a couple videos before that, was about Prometheus and Grafana. If you go to YouTube and search for Prometheus Kubernetes, so that's the video that I did, Prometheus Grafana monitoring for your Kubernetes cluster. So that monitoring, that one is for metrics. So that will tell you how busy your nodes are, and for each pod, what's the CPU usage and what's the memory usage, how many pods are running, how many, and all those metrics, basically. So this one is for monitoring your logs, not the metrics. So it's very important to monitor your logs in Kubernetes. So if you've got a client, monitoring logs, sending logs to the log stash is quite straightforward. But when you've got your Kubernetes cluster, then you would have lots and lots of pods and applications running in your cluster. So the pods come and go, so it won't be permanent. Say for example, in a replica set, you have 3 replicas, for example, and then a node becomes unhealthy or a pod becomes unhealthy and it gets rescheduled on a different node and so on. So it becomes quite difficult for a standard logging mechanism to work. So we've got the Elasticsearch, FluentBit and Kibana stack. So we're gonna set it up right in your brand new cluster and see how it works. Okay, so as usual, I've got some notes for this demo. Okay, so the environment is going to be the Kubernetes cluster will have a master node and 2 worker nodes. All of them are LXC containers running CentOS 7. So they're all having 2 CPU and 2 gig of RAM. And I'm going to be using Rancher to manage this Kubernetes cluster. So I'm not going to run any kubectl command, apart from just one kubectl command just to set up Rancher. But it will be a lot easier to use Rancher to manage your Kubernetes cluster. If you're not used to Rancher, I've done a video on Rancher as well. If you search for Rancher Kubernetes, so the second video here, setup Rancher for Kubernetes. So I would suggest you to watch that video if you haven't used Rancher before. Right, and the way I'm going to install EFK stack in Kubernetes cluster is using Helm. Again, if you're not used to Helm, I'm not promoting my videos, just the way I explain things. If you want to follow along, you can feel free to watch all my previous videos. But I'm not going to use the Helm command line in this demo. I'm going to use Rancher. So using Rancher, we can deploy the EFK stack as a Helm chart. But if you're interested in learning about Helm, so I've done a couple of videos getting started with Helm. So this one here, Helm and Tiller in Kubernetes. So that I've explained quite a bit of introduction to Helm and Tiller and how it works in your Kubernetes cluster. And I've also done a video on how to install Jenkins using Helm. Jenkins Helm Kubernetes. So it's down here, running Jenkins in Kubernetes using Helm. Right. So this EFK stack you can either install using Helm from the command line or using Rancher, which I'm going to show in this video. And if I go back to my notes, right, so Rancher will be a Docker container. I've got my Git repo. I'll show you how to run the Rancher as Docker container. I'll be using Docker Compose to bring up this Rancher container. And all these cluster nodes are LXC containers, lightweight one. And I'm running all these on my host machine, which is a Dell laptop with 4 CPU, 8 gig RAM, and running Manjaro Linux. Okay, when we install EFK stack using Helm, what we're gonna get in our cluster is this one here. So the Elasticsearch, the first bit, will be set up as a cluster with 3 pods. So I've done a video on stateful set. You can search in YouTube stateful set Kubernetes, or you can search in my playlist. So you'll get the pod names as EFK, Elasticsearch 0, 1, and 2. So these are stateful set. And we have Kibana, which is a deployment with 1 replica, and FluentBit, which is going to be a daemon set. So we're not using FluentD, we are using FluentBit, which is a lightweight log shipper. The reason we are deploying it as a daemon set is we are going to deploy FluentBit as a pod on each worker nodes that you've got in your cluster. That's because the FluentBit pod will be sitting on each of the worker nodes, and it will listen to the logs from all the pods that are running on each of the worker nodes. So that's the reason we have to deploy FluentBit as a daemon set, so that it gets run on all the worker nodes. And all these resources will get deployed in a separate namespace called EFK, which will get created as part of Helm installation. Okay, so cd to play directory. I'm gonna git clone my Kubernetes repository. The link will be in the description if you want it. Cd to Kubernetes, and then cd to Rancher. So in this directory, I've got a docker compose .yaml file. Please make sure you install Docker and Docker Compose on your distribution, and then you can run Docker Compose up -d. So that's going to create the Docker container. Docker Compose logs -f. We need to give it a few seconds so that it's completely up and running. And while it's doing that, you can watch the logs, what it's doing. It won't take long. It will take a few seconds. Say you could just wait for like 30 seconds for it to come up. And once that's done, we're gonna go to the browser and type in localhost. So it will be listening on localhost, and it will redirect us to the HTTPS site. So it's updating the catalog library at the moment. Meanwhile, if you want to know about stateful set, you can see stateful set Kubernetes, and the first video here, how to use stateful sets in Kubernetes cluster. Okay, I think it should all be done. I'm gonna exit out of it, and if I go to the browser and type localhost, so it's redirecting me to the HTTPS site. So that's the default page. You need to set the admin password. Just set any password. I've set it as admin, and click continue. And this one, you need to enter the IP address of the machine where you're running Rancher. So all the worker nodes in your Kubernetes cluster should be able to reach this Rancher instance. So it's better to use the IP address. So mine is 10.95.67.28. Save URL. I'm going to add a cluster, and I'm going to import an existing cluster because I've got a Kubernetes cluster already using the LXC containers. kubectl get nodes. So I've got these 3 nodes, kubectl version -- short. I'm on version 1.13. Excuse me. Okay, so we need to give it a name. Cluster name, let's call it just me, and click create. So it's gonna give a command that we need to run, copy this command, the last one, and then run in your cluster. Okay, so that it has created lots of resources. We need to wait for a while to the cluster to be completely imported. So back in here, if I click done, you can see waiting for the full cluster configuration. So I'm going to pause the video here. It's going to take about a minute or so to import the cluster. So at the moment it's deploying all the nodes, all the pods and all the resources in your cluster so that Rancher can manage your cluster. Alright, the cluster is completely imported now, and if I click my cluster name, you can see that's my cluster, and you can see the nodes kmaster, kworker1 and kworker2. Okay, so the next thing I'm going to do is I'm going to go to the default namespace and click on the catalog apps and click launch. So when you set up Rancher, it will, let me show you that. Go to global and look at the catalogs. You can see the catalog library is enabled, so you can launch some predefined Helm charts. So when you set up Rancher, it's going to enable the default repository. So click on launch, and you'll have lots of applications here that you can deploy using Helm. So I'm going to be using the EFK here. So view details. If you want, you can read through all the detailed description, what it will be doing and what sort of resources it will be deploying and so on. Okay, name of the application, let's leave it as EFK. You can see here this application will be deployed into EFK namespace. If you want it to deploy in a different namespace, you can customize it. And there are a few options that we can set. Use the default image, true. If you want to use any other images, you can select false, and that will give you an option to select which image that you want to pull. So let's go with the default image, and you need to make sure that you've got at least half a gig of memory on each of your worker node, because Elasticsearch is a Java application and it's memory hungry application. Okay, Elasticsearch service type, I don't want it to be node port. Let it be cluster IP, because I'm not going to be using it. I'm not going to access the Elasticsearch service from outside the cluster. The only thing I'll be accessing is the Kibana dashboard. So the Kibana dashboard, we can make it a node port, but for Elasticsearch, let's leave it as cluster IP. Elasticsearch persistent volume. So for demo purpose, I'm not going to use the persistent volume. I'm going to leave it as false. But if you're using it in a production environment, you need to make sure that the Elasticsearch stateful set has got a persistent volume, because when you stop and start your stateful set, or if you delete and recreate it, all the data that's stored in your Elasticsearch cluster will be lost. So make sure you've got persistent volume enabled. And on bare metal, if you want to have persistent volume, I've done a video on that one as well. Go to YouTube and search for dynamic NFS provisioning. If I spell it correctly, Kubernetes. So dynamic NFS provisioning. So that's the video that I did. You can follow that video, and if you've done that bit, and if the dynamic provision is enabled in your cluster, you can select true here, and it will ask you what storage class to use. If you've deployed the dynamic NFS provisioning, you would have created a storage class, and you can select that storage class, and you can define how much space you want and so on. But for this demo purpose, I'm just going to leave it as false. I'm not going to use any persistent volume. Expose Kibana using load balancer. I don't have load balancer. I'm going to leave it as, I'm going to change that to false. So if you set the false option, then it's going to create a node port service. But anyways, you'll be able to access Kibana using node port. So the FluentBit, do you want to enable FluentBit? Yes, definitely true. And if you want to take a look at the values file, there's a preview section here which you can look. So that's the values file. Let's go ahead and launch this. Okay, so I'm launching it, and if I click EFK, you can see workloads. So all of them are getting deployed. It's gonna take a while. When I tried testing this video, it took about 5 minutes because it's going to download lots of container images. As you can see here, Elasticsearch is a stateful set, looking at this icon, and it's creating 3 pods. And FluentBit is the daemon set. Here you can see the icon for the daemon set, and the Kibana is a deployment with just 1 replica. So I'm gonna wait. I'm gonna pause the video and wait for the application to completely get up and running, and I'll come back when it's ready. Alright, EFK stack is completely deployed now. It took about 3 to 4 minutes. Now you can see the Elasticsearch stateful set is complete with the 3 pods. You can see the name here: EFK Elasticsearch 0, EFK Elasticsearch 1, and EFK Elasticsearch 2. And FluentBit is a daemon set with 2 pods because we've got 2 worker nodes, and Kibana is a deployment. You can access Kibana dashboard using Noteport. If you just click this link here, it will take you to the Kibana dashboard. Okay, it's loading the dashboard now. If you go to Discover, and you need to add the index. So it has created the Kubernetes cluster index. If you type in star and click next step. Okay, now we need to select the time filter field. So select timestamp, create index pattern. Okay, it's all ready. If I go to Discover again, you will be seeing the logs shortly if it worked. Cool. So we've got all these logs. Basically, these are your Kubernetes cluster logs. Logs from your Kubernetes cluster, logs from your all your individual pods. Okay, you can see all the various fields here. Kubernetes host, namespace, pod name, container name, and so on. Okay, let's try and filter something. If you want to search for the logs from, for example, you've got these pods here. So what's the name of this pod? EFK. No, that's not easily readable. Okay, EFK-Elasticsearch-0. If you want to look at the logs for that pod, what we can do is you can type in here EFK Elasticsearch-0. Right, so these are the logs from that particular pod. You can either do it this way, or let's go back to how it was, and you can add a filter. Okay, add a filter, and if you start typing Kubernetes, it will show you all the available filters that you can use. Container name, host, if you want to use a specific host. So I want logs of all the pods running on host K worker 1. Let's see if that comes up. I need to click save. Yep, Kubernetes.host K worker 1. So we've got all the logs from all the pods running on K worker 1. Okay, let's edit this filter and say Kubernetes dot pod underscore name is EFK Elasticsearch dash 1, for example. Click save, and let's see if it comes up. Yep, Kubernetes dot pod name EFK Elasticsearch dash 1. Cool. So the log entry is here. So that's the log entry. and these are other fields. For example, it tells you this pod is on the namespace EFK, namespace underscore name. So you can also do Kubernetes dot namespace underscore name is EFK. Is EFK save. So this will filter all the logs from all the pods, all the resources in your EFK namespace. Okay, let's edit it and say we want it from Kube system namespace. Save, no result. Kubernetes.namespace underscore name is Kube system default. No result. Okay, it's better to search here. Kube system. No results. Okay, I'm gonna leave that with you to play with. So basically, that's it. So you can look at custom logs. Say if you want logs from today, there are some predefined time range, or there's relative time range. I want for the last 15 minutes, or for the last 15 days, or absolute, exactly from which date to which date. You can do basically all sorts of Kibana filtering, log filtering. Okay, so that's it. So that's just the raw logs from all your pods in your cluster. So that's how you manage logs. So when it comes to monitoring and watching logs, it's very essential that you keep an eye on your logs. So you don't have to, if you don't have this solution EFK, so what would you do? You would have to go into each of those pods, for example, this pod, and then you go in here, click view logs, and you see the logs here, right? Or if you're using kubectl, you would go to kubectl logs EFK Elasticsearch kubectl -n EFK logs EFK Elasticsearch -0. So that's how you would see logs. So if you want to look at the logs, you would go into each of the pods and then you have to view the logs. So deploying an EFK solution is very easy. You can manage your logs centrally. You can filter, you can search for logs across your cluster. So it's definitely useful. Cool. I think that's all I wanted to show you in this video. Right. Okay, I hope you found this one informative and useful. If you liked it, please share it with your friends and don't forget to subscribe to my channel. I've got a few more videos waiting to be released. Following this video, if you have any doubts or if something is not working for you, please leave me a comment. I should be able to get back to you at the earliest as I can. Okay, thank you so much for your time watching this video. Bye bye. See you all in my next video.